Now come to the question number 2 in the exercise 5.6, page number 181, question number 2. If x and y are connected parametrically by x is equal to a cos theta, y is equal to b sin theta. Here the variables x and y are connected parametrically. By observing these two equations, can you find out what is the parameter? Yes, theta, not A, B. A, B, C, these are always considered as constants, arbitrary constants. Okay, my children, remember this point always. Without eliminating the parameter, find dy by dx. Understood the question, my dear children? We had to find dy by dx without eliminating the parameter. Okay, my dear children, come to the solution part. I wrote the given parametric equations separately. Here x is equal to a cos theta. This side I wrote y is equal to b sin theta. In examination, no need to write like this only. You can find first dx by d theta. After that, you can find dy by d theta. Understood, my dear children? It is not compulsory to write like this only in examination. Okay, my dear children? Right. So x is equal to a cos theta. We have identified what is the parameter? Theta. So we have to differentiate on both sides with respect to theta. In the previous question, the parameter is t. So we differentiated x and y with respect to t. Whereas in this case, the parameter is theta. That is why we have to differentiate x and y with respect to theta. Understood this point, my dear children? Right. So I wrote this step. Understood this step, my dear children? Right. This implies what is the differential operator then? Yes, d by d theta. So d by d theta of x is equal to d by d theta of a cos theta. In this step, I wrote only differential operator on both sides. Understood this step, my dear children? Right. This implies d by d theta of x is equal to dx by d theta only. So in LHS, I wrote dx by d theta. Understood LHS part, my dear children? Right. Is equal to, come to RHS part. Here d by d theta of a cos theta is there. If you observe in this function, a is a numerical coefficient, arbitrary constant. We can say it as a arbitrary constant. So we can write it before the differential operator. We can take it out from the differential operator. So I wrote here before the differential operator, I wrote a. Then d by d theta of what will be left here? Cos theta. Understood this part, my dear children? Right. I wrote here reason also. D by d theta of x is equal to dx by d theta. Understood, my dear children? Right. Come to this side. Come this side here. Y is equal to b sin theta. We have taken second equation. We have already found the parameter is t. So we differentiate on both sides with respect to theta. Understood, my dear children? Right. So what is the differential operator? Previously I wrote d by d theta. So on both sides we write d by d theta. The differential operator is here d by d theta. So d by d theta of y is equal to d by d theta of b sin theta. Understood this step, my dear children? Right. This implies d by d theta of y is equal to dy by d theta only. Understood this LHS part, my dear children? Right. Is equal to, if you observe this one function, here b is a numerical coefficient, an arbitrary constant. So we can write it before the differential operator. We can take it out. So I wrote b outside. Before the differential operator, I wrote it. After that, I wrote d by d theta, differential operator, into d by d theta of, what is there? What is left here? Sin theta. Understood this part, my dear children? Right. I wrote here reason also, because d by d theta of y is equal to dy by d theta. Understood this step, my dear children? Right. Now come this side, dx by d theta is equal to a into d by d theta of cos theta is there. LHS I wrote as it is equal to a numerical coefficient, I wrote it as it is. We have to simplify this part, d by d theta of cos theta. It is in the form of d by dx of cos x. In the place of x here, theta is there. You observed the point, my children? Right. So we use that formula here. It is a suitable formula here to find the value of this one. Okay, my children? So minus a sin theta, because d by dx of cos x is equal to minus a sin x. Understood this part, my children? Right. This implies dx by d theta, I wrote LHS part as it is. Differential part is over, differentiation part is completed. Just we have to write its simplest form, it's a simplification. So a into minus sin theta, what will get here? Minus a sin theta. Understood RHS part, my children? Right. Now come to this step. Dy by d theta is equal to b into dy d theta of sin theta. I wrote LHS part as it is. Dy by d theta is equal to, in RHS we wrote b as it is. If you observe this point, it is in the form of d by dx of sin x. Isn't it, my dear children, or not? Yes, it is in the form of d by dx of sin x. In the place of x here, just letter is changed, variable changed, theta is there. Isn't it or not, my dear children? Yes. So cos theta, because d by dx of sin x is equal to cos x. Understood this formula, my dear children? Understood this step, my dear children? Right. This implies differentiation part is over. Next we have to write the simplification part. So LHS I wrote as it is, dy by d theta is equal to, come to RHS, we have to simplify this part, b into cos theta. Understood this part, my dear children, in RHS? Right. We have found here dx by d theta. Here we found dy by d theta. Now we have to find dy by dx. Actually the question is we have to find dy by dx. Therefore dy by dx is equal to dy by d theta by dx by d theta. Okay, my dear children? Right. Is equal to dy by d theta. What is the value of dy by d theta? B cos theta. By what is the value of dx by d theta? Minus a sin theta. We have to substitute the values here. Understood this step, my dear children? Right. That is equal to minus b by a. Understood this part, my dear children? Right. Cos theta by sin theta. What will you get here? Cos theta by sin theta means cot theta, because cos theta by sin theta is equal to cot theta. In the trigonometric functions chapter, you know this formula. Isn't it or not, my dear children? Right. So dy by dx is equal to minus b by a cot theta. Understood, my dear children? Right. If you observe the question number 2, just I changed the function. Actually the function is a cos theta and y is equal to b cos theta, but I changed the function, y is equal to b sin theta. Just I changed it. Okay, my dear children, but procedure is the same. Can you do the sums? Question number 2, 3, 4 and 5? Will you try the questions number 2, 3, 4 in the exercise 5.6, my dear children? Please try the question number 2, 3 and 4. This is actually not question number 2. I have changed the function. Understand that, my dear children? Yes. So please do the sums, question number 2, 3 and 4 in the exercise 5.6 and show it through your WhatsApp number. Okay, my dear children? Right.